Hello and welcome to our first video lesson of the year. I'm sure you guys are going to find this a little bit odd, and I find it very odd, but we'll get used to it together. For the next few weeks, we're going to be looking at geometry. And you guys would have covered a little bit of this in primary school, but probably never put a word to what it means. But if I said to you, name as many shapes as you can, there's a bit of geometry. So all we're looking at is shapes, really. It dates back to 3000 BC in ancient Egypt and Babylonia. Essentially, back then they would only do very practical problems. So they were trying to find the area of a field, or I don't know, finding how many tiles you can fit on a floor or something. Very basic practical problems. But at the end of the day, it's all about shapes. It's the study of shapes. So first of all, where does the word geometry come from? And we have the River Nile in Egypt. The River Nile used to always burst its banks pretty regularly back then, because they didn't have any defences for it. And the River Nile really, it destroyed walls for people's land, so that after the flood had happened, nobody knew where their walls were, or what was their land, what was not their land, So essentially what people did was they came along with long pieces of rope, they stretched them along, and they had already recorded before it had been washed away how big their land was. So they would know on the rope how far to go, and once that was done, they'd rebuild the wall. And these people were called rope stretchers. And essentially what they were doing was measuring the land, okay? So measuring the land, if we then think about those two words and then look at the word geometry, geo, we think of the word land or earth, think of geography, and metry, which is pretty much the word measure, what we have today. So land, measure, put them together, we've got geometry, okay? So back then, essentially, geometry was just looking at the land and measuring it, trying to get practical solutions to problems. Take a little trip to 300 BC, from 3000 to 300 BC. And we meet a guy called Euclid. Okay, so Euclid was a very important person when it comes to geometry, probably the most important, and is probably known as the most important teacher of maths ever. He went off around what is now Greece, really, but it's kind of a bit of everything. And he was traveling around that whole area looking for all of these geometric things that people were doing. So a lot of stuff that we think that he wrote, he probably didn't write, he probably just collected a lot of stuff. But this is the first ever time that he made a book, anyone made a book, that was all of what we knew at the time in one place. And this was really revolutionary. And this is the book here. It's called Euclid's Elements. And it's 13 different books. And essentially this book, it's pretty big. What it does at the very start of the book, if I can get the first little bit, is he outlines very basic rules, definitions as he calls them here, of what a point is, a line, a straight line, a surface, all of these things that would then set up what he called propositions. So we have proposition 1, which is basically the basics of what you can do with what we know so far. Proposition 2 comes in, and you need to be able to know what proposition 1 is to do proposition 2. And this follows on for all 13 books. So for proposition 4, you need to be able to know how to do number 3, number 2, and number 1. And nobody had ever done this before. It seems pretty logical now, when we think about it, that to know the end of the book, you need to know all the start of the book. But it wasn't that straightforward. And a lot of these things are what you're going to be doing in geometry. So essentially, his first book is a lot of what we do. So here's one: bisect a given straight line, a finite line. So to split in half a line, which is one of the things you will end up doing. So, very interestingly, he's done stuff that now we're actually doing, and that's how important he was. That's Euclid, and I'll put up a few things on your Google Classroom just to have a look at in relation to him. But for now, we're going to look at some definitions for our study of geometry. So to start off, the plane. The plane is essentially where we are working. So it's a flat surface where we do all of our work on. Now, it's sometimes hard to get your head around this. People go, "Whoa, where's the plane?" But the plane is anything you're writing on. So your copybook that you're going to be doing some work on is the plane that you're working on. It's just a flat surface that we can show our work on. We then have points. So that we call these dots. These are literally the dots that we put on the page, and these make up the plane. And don't get too caught up on this, but the plane is a set of points. So the area that we're using is all these points, and it's actually an infinite set of points. So you could put as many points as you want onto the plane. Don't worry too much about that. It's just a little bit of info. And here's just a little example. So this here is my plane. I've got point A, point B, and point C, and we always denote our points by capital letters. Okay, and we usually start A, B, C and continue on. You'll see that as we go on. So now the line. So a line we call, in this case, we're going to call it BC. Looks like this. I'll do it this way so you can just see that. Okay. The line BC here, as you can see, it's a line. We have a point B and a point C that are on the same line. We call it the line BC because this line does not stop here. Okay, as you can see, we have two arrows at the end. The arrows just mean that this line continues on forever and ever and ever and ever, all as long as you can. You'll never stop on that line. So this line BC goes on forever. You can also write a line like this with this little L. It's just an L. I just write my L's fancy. Don't worry about that. And again, it's just a line. You call this the line L. So just looking at this again, we just think about this for a second. If say if we had this letter was A and this letter was D, then the line would be called AD. Or you can call it DA. As in here, we can call it BC or CB. So don't get too worried about the letters. Next, we have a ray. Now, notice the difference between how we've written this. The ray has a bracket before the B and not up here. Now, why do we have that bracket? If we look at the difference, we have BC. Sorry, I'll get that so you can only see this. We have BC. Now, the line doesn't continue past B. And that's what that bracket means. It means it's closed off at B. So it stops at B, goes through C, and goes on forever. But this is called a ray. So a ray is just a line that stops at one point and continues on forever at another point. So be careful with your notation of this. Make sure that you remember that bracket. And it's definitely a square bracket. It's not a roundy one. It's a square bracket, okay? Now we have a line segment. Now we've got loads of brackets. We've got two brackets, one on either end. So if you've thought about this one and why we have a bracket, you'll probably be able to figure out here. So have a little think. We've got one bracket here. Now we have two brackets. We've one on either end. If the bracket here meant to be closed off here, well then look, we've got a line segment. It's a line, clearly, but it stops at both ends. So a segment of something is always like a portion of something. It's a portion of a line. A line is something that goes on forever. This line segment is just this section of it. The line AB. A line segment AB. We can also call it BA. So it's not just a line segment AB, it's BA as well. I just called it AB because that makes more sense. We all know the alphabet. Finally, we have a point of intersection. Now this one is pretty straightforward. Think of it. Point, we know, is just one of those dots. Intersection is where two things cross. So an intersection of two roads is where they cross, isn't it? So now we're going to look at this. Before I show you the answer, I know this is really strange, but just think about which one do you think is the point of intersection in here. Is it A, B, C, D, or E? While I explain this, try and figure that out. So we've got AB. We'll start with our alphabet, AB. Is this a line, a ray, or a line segment? So we've got it stopped at one end, it goes through another point, and then goes on forever. Now, just because I haven't drawn the arrow, which I probably should do, so I'll edit that now. We meant to have arrows here, here, and here. Apologies. So we have that A, B, and E thing going on here. Now, from my looking back at these three, it very much looks like a ray. So we've got a ray AB that goes through E. Then we've got this other line here, CD here. Now, it doesn't look like a line segment because it goes on both ends. It's not a ray because it doesn't stop anywhere. It's definitely a line. Okay, so we've got a line CD. So we've got the ray AB, the line CD, and we've got this point E in the middle. So the point of intersection, where those two different things meet, those two different types of lines, we've got a line and a ray. Where the line and the ray meet, here is our point of intersection, which is called E. Okay, so looking down here, I'm just going to explain this a little bit here. We've got a ray AB, so we know that the ray has to have that square bracket where it stops. So we've got that square bracket there, that's correct. AB, forget about the end for a second. CD is just like this, the line CD that we have, equals E. So this N thing, if we can think back to our sets, and I'll just draw out something now for a second. If we can think back to sets, we had circle, apologies for the bad circles. And we had this section here. If we remember, if this is called A and this is called B, then this section in the middle was called A intersection B. This thing here is called an intersection. Okay, so now going back to this, we've got the ray AB intersection, the line CD is equal to E. There. So let that sink in. So we only have three different types of lines. We've got the line where it doesn't stop, the line where it stops once, and the line where it stops twice. Okay, so you'll be glad to know there's something for you to do. On page, I didn't even write down the page number, on page 147, so let me put that in, on page 147 of your textbook, Connected Maths, I want you to do all of activity 8.1, so it's 147 and 148, sorry. You have questions on doing just little small things. It's not very long really. It looks really long, but it's not. So what I want you to do is to submit it as a picture of your copybook, if you can, because that's the only way you're going to be able to do it. So a picture of what you've been doing is the best way to do it. I know a lot of you have been handing in like that, but if you haven't, just do that. It's easier. One thing I've added in, and this will be in the instructions, is for question IV, this one here, it's on page 147, that one. I want you to give me a reason for whatever you have found. So it says, could you draw a different line that also passes through A and B? You'll understand that when you get there. I want you to give me a reason why you say yes or no. It doesn't ask you for it. It says discuss in class, so I want you to actually write that down. Other than that, I hope that makes sense. I'll have a few other materials up on the Google Classroom and the Padlet for you to just look through in case you're a bit confused about little things. But if you can understand that there are three different types of lines, that we have points on those lines, and you can draw them, then you're all good.